VLSos here. This is a video lesson system. I'm going to provide two examples here. One will be an example of what we're going to call a system, and one is not. The first one is not a system. We're going to give an example of a single equation, y is equal to x plus 3, and compare it to an example that is a system. These two equations, y is equal to x plus 3, and also at the same time, another equation, y is equal to negative 2x plus 6. And we're going to group these two equations with this bracket. We could call that a system bracket because we want to consider both equations at the same time. And we'll say more about that in just a minute. What a system is a problem or a situation that is considering more than one relation or equation We often make systems out of equations, but we can use other relations like inequalities. More than one relation or equation using the same variables. So how does that change our approach to the problem? Well, in this example, where we only have one equation, we would consider a solution, and there are many. In this case, a solution to this single equation might be the point 1, 4, or the ordered pair 1, 4. The first value 1 in an ordered pair that we would graph is x. This second value is y. This is a solution because if I substitute these values in for x and y, then I would get the equation, the y value of 4 is equal to the x value of 1 plus 3. And I can confirm that this is true. When I substitute these values in for x and y, those are values that make the equation true. And I've shown it that 4 is equal to 4. So we call this a solution. In general, a solution is what we call values, or any values, for the variables in our equation or a problem that make an equation true. In this example, we had a single equation, and we found values that, when substituted in for the variables, make the equation true. This equation has many solutions. In our system, we have two equations being considered at the same time, which means that if we were to find a solution to this system, we would need to be finding values for the variables in all of the equations that make all of the equations true at the same time. We can make a note. The solution to a system must make all equations true. So if we find a value for x and y that make this equation true, like the value 1 for x and 4 for y, then it would be a solution to this system if the very same numbers, when substituted into the second equation, made the second equation true also. We could test that. If we substitute 1 in for x, then we get -2 times 1 is -2. -2 plus 6 is 4, and that's equal to the y value of 4. So this pair of numbers for x and y is also a solution to this system. We're going to talk about strategies for solving systems in the future. Solving systems is more sophisticated, usually, than solving a single equation.